Yes, no, I know. But sometimes, like, this should all be done. This is just checking over, but that's cool. I don't mind. I've got it all set up to go. By the way, did anybody watch the video yesterday with the, when I was moving around the microphone? Was it fun? Did you watch it, Jordy? Yeah. My special guest hosts? Yeah. All right. Anyway, this was 6x cubed y, and that was 4x minus 3. That was x plus 9, x minus 9. That was x to the fourth, x squared plus 16, and x squared minus 16. If you left this like that today, that's okay. But in half an hour from now, you should know that that wouldn't stay that way, if you don't already. Okay? Now, 8, 9, and 10, I told you were a little bit tricky. Observe. Pretend that I wrote this expression if I wrote it as follows. xy plus 3y. What would you do with that? You would factor out a y because they are both, the y is common to both of them, yes? So you would divide by y, write a y at the front, and then write these answers, yes? X plus 3, agreed? Okay, good. All of you saw that immediately, right? Okay, so all of you should also have seen x minus 2 and x minus 2 are factors, aren't they? Because they're grouped together by brackets, aren't they? And are they not factors of both terms? So what I should have done there was divide by x minus 2 and divide by x minus 2. Because, of course, brackets hold it together, yes? So that makes this the greatest common factor. So then I would write it at the front, and then I would write the quotients. Cancel, x, cancel, plus 3. How many people figured that one out without doing distribution? Because, of course, you would also have been allowed to go x squared minus 2x plus 3x minus 6, x squared plus x minus 6, and then factor that too, right? You could have done that. But I submit that this way is both faster and more elegant. And if we seek nothing in math, we should seek elegance. Right? Like we should be taking these trinomials out in ball gowns and tuxes. Yeah? Right. So, now that you know what you could do, you have two options for a question like 9, right? Of course, the easier one, in my view, is to see that that is one single factor, isn't it? And it occurs in both terms. So we would divide by a minus b. And then it would go to the front. Cancel, cancel. Oh, 2a. Cancel, cancel. Plus b. Yeah? Yeah. Now, what's weird about 10? Because everybody should have tried it. What's weird about 10? Mantage.
They have, so how you said before in 9, in the brackets, they are exactly the same variables and in the same order.
Yeah.
But in 10, they're in different orders.
Right. They're the same numbers, but if we were to go back to those algebra tiles that you all hate so much, how would you draw 2x? You'd draw 2 bars and then 3 dark little guys, right? And then for this one, you would draw 3 white, unshaded, and 2 shaded in bars. Yeah? Now they look similar, but you can quite plainly see they are different, yes? But we know that we are allowed to do certain things to mathematical expressions that don't change their values, right? For example, 1/2 equals 4/8. Does this look totally different than this? But they are the same, are they not? So what were we allowed to do to this to make it this? I was able to multiply by 4, yeah? All right. And then if I give you something like this, 3/15, you can make that look different, can't you? How? Division, right? So multiplying and dividing allows you to change the way something looks without changing its value. Agreed? All right. So what could I divide by here that would keep the value, keep the numbers 3 and the number 2 the same? What do you divide by that will not change? What? 1. Excellent. But I also need to change that to a negative, don't I? What can I divide by that would change a positive to a negative? Negative 1. Right? Now, if I divide by negative 1, does that not mean the greatest common factor comes out there? Right? And what is 3 divided by negative 1? Negative 3. And what is negative 2x divided by negative 1? Positive 2x. But there was already a negative 5 out here. What did we do with radicals when we brought something out and there was already a coefficient? We multiplied it. So what do you think we do with negative 1 and negative 5? Multiply it. So my new expression is x, 2x minus 3. Now what? Plus 5. And then 2x minus 3. And now we're in business. Right? Because I can always divide by 1, can't I? Now I have 2x minus 3, and I have x plus 5. Right? Now, don't write down what I'm about to write down, or do if you want. Sometimes kids don't believe me. Right, Mr. Myers, that seems shady. I think you're messing with us. I don't think that's okay. So I say, okay, kid, let's do this. Pretend that, you don't even have to pretend because I will make it magically disappear, like Lucky and his Lucky Charms. They're magically delicious. If you distribute that, what do you get? Negative 15 plus 10x. Agreed? Okay. If you do my magic move, you get 5, 2x minus 3, right? Distribute that. What do you get? 10x minus 15. Everybody agree? Everybody see how it works? Magic. But it isn't. Right? Because just like magic, everything that happens in magic is really happening somewhere, but not really happening. Because it's fake. Math, not like that. Math is real. Kinda. And then, of course, 2 expansions. Is this x cubed plus 27? No. What is it really? It is x plus 3, x plus 3, x plus 3. Right? Now, there's a handy-dandy little shortcut that will allow you to do this. I will not teach you that little shortcut for 2 reasons. 1, every time you learn a shortcut, you waste brain power on something that you could actually learn how to do. And 2, because you don't actually learn how to do it, you start bringing that shortcut to the party, and then you do the wrong thing because you get confused as to which shortcuts to use. Right? I hearken your mind back to exponent laws. All of you would tell me that you would subtract there, right? But a bunch of you would get that answer wrong because you're learning the shortcut, not recognizing that that should be up there and it's x to the 7th, right? So I'm not going to show you that little shortcut. If you wish to learn that shortcut, by all means, Google it. What I do here is actually multiply it out. And I always leave the first one and do this one. Because this one you can do with our little shortcut, can't we? It's x squared plus 6x plus 9. You don't even have to think about it. 3 plus 3, 3 times 3. And then, how many distributions do I need here? 3 with the x, and how many with the y? 3 with the y, which means I need a total of 6 distributions, yes? Now, of course, I have shown you I like to go take the x and run it all the way through. X cubed plus 6x squared plus 9x. Then I like to take the 3 and run it all the way through. 3x squared. And I like to line up my like terms. Then it's impossible to miss one when you are collecting like terms. I say that because in 20 years of marking math tests, many, many times I see kids leaving out a term because they've written it out horizontally like a previous teacher taught them, and then they've done there's a triangle, there's squares, there's circles, and they try to add up all those shapes. I'm sure you've been taught that. There's nothing wrong with that. It works fine, except when you get to bigger and bigger polynomials, you got a lot of shapes. And I've seen kids sit there like this. Okay, the x squareds are a triangle. The x's are a square. The singles are a circle. But there may be an x4 and an x5 in there. And then I see kids stress about what shape to draw around the term. Not a word of a lie. They will sit there and they will look at numbers and they'll be like, I've already used triangle, square, and circle. Don't. Do math. Now, don't, period. Do math. Not don't do math. All right? Do math. That's why I stack these up. Anyway, plus 18x plus 27. And then, of course, you just draw a line. X cubed plus 0 is x cubed. 6 plus 3 is 9x squared. 9 plus 18 is 27x. And 0 plus 27 is 27. Then you don't have to do all that crazy square circle stuff, and your polynomials don't stretch halfway across the page. But if you are comfortable doing that, should you change for me? No. Don't. Okay? Okay. And then this one is, of course, 4x squared minus 6xy plus 20xy minus 12y squared, which is 4x squared plus 14xy minus 12y squared. Yeah? Yeah. All right. Turn the page over to page 80. Now, ladies and gentlemen, yesterday when Raj was my guest host, he started doing some work. And he did some factoring. He did... when Raj was my guest host, Raj did this one right here. And Raj was like, and then I will just do, and I said, stop. And he said, but I'm not wrong. And I said, I know you're not wrong, Raj, but don't give me away because I'm going to do that tomorrow. That was yesterday. Yesterday means today is tomorrow from yesterday, right? Right. I'm reading this cool book where the main character is trying to ascertain how memory works because her mother has Alzheimer's disease, and she's trying to figure out, because your brain is just electricity, right? She's trying to figure out the electrical path of memories in your brain, put them into a computer because it's just ones and zeros, and then be able to put memories back into the brains of Alzheimer's patients. Everybody with me? Because her belief is time isn't real, right? The only reason we know time is passing is because we are getting stimulation from it, right? By the time I finish this sentence, it's already in the past. So we make that up. Our brain has created time. Everybody with me? Okay. So her thing is, let's figure it out. But this other guy in the book, who's the super rich guy, is not working on that. He believes that, yes, time is not real because everything is the present, because the past and the future are all constructions of your mind, which means everything is only happening right now. So he uses her technology to go back in time, like actually go back in time. It's a really cool book. But it's getting a little confusing because when you go back in time, when you catch up to the time that you left, your original time, you get all your memories of both times back. And then people's brains explode. It's really neat. It's a little hard to follow, though, because I read it at night and I start to fall asleep, and I'm like, what the hell? What? Then I got to flip back 10 pages. Well, I don't, because I read on an electric thing, so I don't actually have to flip back pages. I got to sit there going tap, 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 because I can't remember the page I actually want to find, so I couldn't just go to the contents and go there. I got to go tap, tap, tap. It's a pain in the ass. But that's beside the point. Why did I start all this? Oh, yesterday was today's tomorrow. Right. Now is now. Now is yesterday's future now. So let's do this. Okay? Okay. All right. Forgetting factoring, because this is already factored, isn't it? Right? Okay? If we were to expand this, what would we get? X squared minus 4x. Then we go to a new line, and we'd have plus 4x minus 16. Yes? And just like in my first parts, when I was hinting at this, I would write x squared plus 0x minus 16. You've seen this construction before, right? You've seen that. Yeah? But we would never write that 0. Why did I put that 0 there? Because at the time, you were doing this kind of factoring. Multiply to 16 and add to 0. And you knew that it was 4 minus 4, right? Which gave you x plus 4, x minus 4, yeah? Now, of course, we would never write that. What we would really write there is x squared minus 16, yes? And of course, I talked about it when we did it this long way. Now I'm going to spend some more time with it. You should notice a pattern there. Yes? Right? What is that pattern? If you are given the binomial, its factored form has two terms. What are they? X and 4. Why is it x and 4? But why is it x and 4 here? They're the square roots, right? Difference of squares. X squared is a square. Subtraction is a difference. 16 is a perfect square, because 16 is really 4 squared, yes? So you should notice that what I did to get from x squared to x is I took a square root. Right? So what did I do here? I took a square root. Everybody with me? So that brings us to this idea. A squared. Does it matter what a is? Any polynomial squared minus some other polynomial squared. Because really this 16 is 4 squared, which is a polynomial, yes? To factor this, we take the square root of the first one. Now, what is the square root of a squared? A. No matter what a is, correct? So it's a plus, then I take the square root of b. What is the square root of b squared? B. And then I just write it again with a minus sign. Why do I need that minus sign? Because I need this middle term to drop out. Everybody cool? So before I go any further, find some white space up near the top. What is the square root of m squared? M. Great. What is the square root of 4m squared? 2m. Yes, RJ.
Could you go in brackets a minus b and then outside the bracket squared?
No, because a minus b squared would be a minus b times a minus b. And then there would be no dropout. What is the square root of m to the 4th? M squared. Okay, what is the square root of 16m to the 6th? 4m cubed. Oh, I'm not fooling anybody. 25 x to the fourth y squared. 5x squared y. You little whippersnappers. What is the square root of x minus 7 squared? I hate, that's the trouble with teaching pre-dip. You actually see patterns. M squared, it was just the m, right? 4m, square root of 4, 2, square root of m, right? So, x minus 7, what do those brackets do to the x minus 7? They hold it together and make it a single thing, right? So isn't this exactly the same as the square root of m squared if m equaled x minus 7? Yeah? Stop it. You kids. All right. I have the second hardest kind of difference of squares is the very first one. Why? Because you practice harder than you play the game. Let's talk. Is that a difference of squares? Yes or no? Yes, of course it is. How do you know? What are the two hints there that let you know that this is a difference of squares? Why is 16 a perfect square? What is it about x to the 16th that makes it a perfect square? What are those two common factors? No. 8. Why is it 8, Jewel? Multiplication of exponents is add. This is, okay, so now that we've said that, is there a square root of x cubed? No. What about the square root of x to the 5th? What about the square root of x to the 27th? What about the square root of x to the 26th? Yes. What about the square root of x to the 49th? Why not, Caden?
Because you can't add two things.
You can't add two things to get 49. So what is the hint to the exponents that allows us to get a square root? Even numbers. Since that's even, it has a square root. What if it was x to the 1024? What would it be? 512. Right? Okay. So, since we know that's a perfect square, we know we can break it up to x to the 8th and x to the 8th. Agreed? Okay. Is 1 a perfect square? Of course it is. Why? Because 1 times 1 is 1. So, plus 1, minus 1. And right there is where about 75% of my students will stop. Even the pre-dip ones. Why? Because I did the shortcut, I did the pattern, I did it, I'm done. I don't need to know nothing about math. I just need to know shortcuts. What's 9 times 7? 63! Right? You don't need to know how to do math because everybody's taught you a shortcut to do everything. Doing math, that's for suckers. Except it's not, is it? What do you see right there? What do you see right there? Subtraction. What do you see right there? Is that a perfect square? Is that a difference? Is that a perfect square? So must I continue? Yes, I must. X to the 8th plus 1. And then what? X to the 4th plus 1 and x to the 4th minus 1. Surely I'm done now. Don't call me Shirley. Am I done? Of course not. Why? X to the 8th plus 1. X to the 4th plus 1. X squared plus 1. And x squared minus 1. Surely I am done now. No, of course I'm not. X to the... Oh, that should have changed color. It would have been much more dramatic. x to the 8th plus 1, x to the 4th plus 1, x squared plus 1, x plus 1, and am I done now? Yes. Does everybody understand? Okay. Now, look at the next one. If that y wasn't there, could you do it? It would be what? X plus the square root of 225, x minus square root of 225, right? Okay. If the x wasn't there, what would it be? Y, same thing. But they're both there. So what is the square root of x squared y squared? xy. Plus, what is the square root of 225? 15. And then I just write it again. Everybody good? I have an answer.
How come we don't factor the x to the 8th plus 1 when we have a negative?
That's a great question. I'm surprised it took that many chunks to get to it.
I was thinking about it, but then I was like, no one else is asking for the question.
Man, Tosh, that hurts. That hurts. I know you've only been in my class for like 4 weeks, but you should know that I love answering me some questions. So, why don't we factor that? How would you want to factor it? You would want to do x to the 4th plus 1 and x to the 4th minus 1. Okay, but isn't 1 times negative 1 negative 1? So that, no, it can't be that. I need a positive 1 here, right? So what do I need for signs here to make this positive? It would have to be negative 1, or it would have to be x to the 4th plus 1 and x to the 4th plus 1, correct? It would have to be one of those two. All right, well, what's x to the 4th times x to the 4th? X to the 8th. Haha, we're in business. What is x to the 4th times negative 1? Negative x to the 4th. What is negative 1 times x to the 4th? Negative x to the 4th. And what's negative 1 times negative 1? Positive 1. X to the 8th minus 2x to the 4th plus 1. It's not there, is it? It only works with differences. All right. Is number 3 going to work? What are the hints that tell us it's going to work? 2 perfect squares. So it is z to the... Z to the what, Harry? You feel ashamed because you gave the right answer a little ahead of time because your brain was moving faster than my pen? You feel ashamed for that? You should not feel ashamed for that. Harry, safe space. I am here for you. Safe space. What is it really going to be? Help Harry out. Make him feel unashamed. 4. He didn't even need our help. He said it anyway because that's how safe this space is. Am I right? Yeah. Some people have the audacity to say that I do not provide a safe space because they are scared. I do not understand. And then, Harry, now go. Yeah. And surely I'm done. Surely I'm done.
Don't call me Shirley.
That's the first thing I wanted. Don't call me Shirley. Or who's Shirley would be acceptable. One day I will get a kid named Shirley. In my 5th year of teaching, I had a kid named Shirley, and I made that joke all the time. And she got really tired of it. Then I started calling her Squirrely. Because she would always get like, when I did the Shirley joke and looked like a squirrel, so then I started calling her Squirrely. And then she got really mad at that. And then she graduated from the school and started working at Hemlock, the ski hill. And I was up there skiing one day with my kids, and I saw her there and I said, hey, Shirley. And she's like, you can call me Squirrely. And I'm like, but, okay, whatever. Because she got really mad when I called her Squirrely at school. I know, right? Oh, I didn't even pick it up. Now, back to this. Why am I making a big deal right now? Because a bunch of you said I'm not done. Why did you say I'm not done? Because you saw an even and a subtraction. You're looking at the pattern. You're not looking at the math. Is that a perfect square? So I'll ask again. Surely I'm done. Yes, you are. All right, 4. Semi-difficult. What is it?
2x cubed minus plus 5.
You can put the minus first. It doesn't matter.
I want the plus first.
I always like to put the plus first too. Plus,
y.
and then
2x cubed minus 5.
everybody cool? Now, obviously, dun dun dun, what does that mean? What does that much white space mean? Damn right I am. All right. 16x squared minus 256y squared. Oh. Oh, worst kind of liar. Make them fourths. Oh, I know, right? I had to erase 2 things. Oh, you North American teenagers have it so rough. Oh. The true IB field trip should be to a school in the middle of the Congo where they're using white or blackboards and pieces of chalk this big. You do not need a calculator for this. What is it? What is? 4x squared plus 16y squared. And then? Am I done? Of course not. 4x squared plus 16y squared. And then?
4x squared minus 16.
No, we already did that one, Mantosh. We're on the end then. Like in that movie, Dude, Where's My Car? Have you seen that movie? The guy tries to order Chinese food, and he calls the Chinese food lady, and he says, yeah, we get some chicken chow mein, and then some pork fried rice. And then the Chinese food lady says, and then, some almond gai ding, and then mugu gai pan, and then beef chop suey, and then, no more and then! Because when you order food from a place like that, that's how you order it. You guys don't know because you don't order food on the phone anymore. You go online. Yeah, it's all online. But if you actually phone a place and order stuff, especially from a restaurant like a Chinese food place or an Indian food place where the dishes are like that, you say, yeah, I'll get some butter chicken and then some aloo gobi and then, right? I love aloo gobi. I think I'm saying it wrong, but I love it. I can't get enough of it, right? It's so good. Man, cauliflower and potatoes, who knew? But, well, apparently everybody in India because it's delicious. Anyway, what's this one? 2x plus 4y and minus 4y. Yay, I didn't fool anyone there. All right? How can you be out of space? No, not plus, damn it. Minus. Oh, I got to erase again. Mr. Myers, you're such a tool. It's all right. I remember being your people's age. What else would I call you? What are you going to do there? Of course you're going to do something. You're going to do that thing that I told you to do.
Oh,
Ah, what are you going to do there?
Factor of 66.
Now what is it?
X squared minus. Six.
Yeah? Okay, I'm sorry, Jewel. There's 2 more things I need to do. Damn!
You have unlimited space.
No, I don't. I'm trying to cram it into this page. I see a bunch of white space up to the right there. Tons. All right. X minus 3 squared minus 16. I know that your first move is to expand that. Should it be? Abso-smurfly not. Because isn't that just a single thing squared? And what is the square root of a single thing squared? The single thing. So what is the square root of that? X minus 3. Plus what? No. 4. And then what? Now, what are you going to do there? You're, of course, going to collect like terms. What is negative 3 plus 4? He waited patiently. 1. And what is negative 3 minus 4? He waited patiently.
1.
X minus 7. No names mentioned.
Keep going.
Keep going. Go, go, go. Right? Everybody see? Everybody see why that works? Okay. All right. And the last one, just to make Jewel really sweat. What is negative 3 minus 4? That's a tricky one. It's obviously 1. Just ask that girl that sits in the front corner, whose name I will not say. No, I would never say anything like that. You guys should see the engagement ring I bought for my wife. It is filled with jewels. All right, the last one. The last one, so the nameless girl in the front can stay cool. X minus 3 squared minus X plus 8 squared. Oh, stop it. Why have you got to be that way, Mr. Myers? 'Cause I do. But is that any more difficult? No. Is it a difference of squares? Of course it is. What's the square root of the first one? X minus 3. Plus, what's the square root of the second one? X plus 8. Then I do the same thing. X minus 3 minus X plus 8. Yes?
Yes.
What is X plus X? It's not tricky. 2X. What is negative 3 plus 8?
5.
Nice job, nameless girl. What is X minus X? Gone. What is negative 3 minus 8? Negative 11. Done.
Cool.
Everybody with me? See how you are having to bring your grade 9 math knowledge to this grade 10 concept? Guess what's going to happen next year? You're going to have to bring that grade 9 math knowledge and that grade 10 math knowledge and learn something new in IB year 1 and then, no more and then put it all together.
No.
All right? All right. It is 9:06. You do page 81. Please notice there are all manner of factoring on page 81. That is your job today. And please notice, what's the next thing on the side? Quiz. When will we do that quiz? Will it be after we go over this page or before? After. I am glad, because I would never quiz you on something that you haven't seen the right answers to. Yes, go.